Hey guys, what's up? My name is Gabe and this is Games with Gabe. If you recall from the last Python tutorial, what we did was we went over the while loops and I gave you a practice problem, which was to try and implement that Wikipedia article's for loop in Python. And so right here I have it implemented just in case you wanted to see the solution. And so basically we just start off with the user entering a number, and then we set s equal to x, since that's what the Wikipedia article states s should be, and then we initialize x sub n to be 1, and then we simply say for I in range 10. So this is just our precision. The more loops you do, the higher precision you will get in your estimate of the square root. So I set it to 10, which seems to give some pretty good results. Then you just say x equals 0.5 times xn plus s over xn, which is exactly the algorithm that was in the Wikipedia article. And then you set xn equal to x so that it resets for the next iteration. And then it prints out an estimation. And so if we run this, you see that when I press 4, you get 2. And then if I do 25, you get 5, which is the square root. And then if I do 2, if I can type this right, if I do square root of 2, we get 1.4, blah, 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 which is pretty accurate. Could be more accurate, and the more loops we do, the more accurate that would be. So that's the solution to that problem. In this tutorial, what we're going to be going over is functions. This is the next sort of big thing in programming that you should definitely know. And we've actually been using these quite a bit, just kind of in disguise. And so what I'm going to kind of go over and explain what a function is, and then we're going to go over how to make a function in Python. So let's first see what a function is. What is a function? If you recall from mathematics, if you've gone up to algebra at any sort of level, then you may have seen something that looks like this. You have f of x equals, and then you say like x squared. And so all this is it's a mathematical function. You have your function f of x, and then you have your equation, which is basically just what you do with this function. If you haven't seen this, don't worry, I'm going to explain how it all works. So basically, the way this works is if I said, okay, what is f of 2, then I would go everywhere I see an x inside of the equation, I replace that with whatever's inside of here, which is a 2. So I would say f of 2 equals 2 squared, which is equal to 4. So then we could also define different types of equations. We could say f of x equals x plus 1. And then if I said what's f of 10, then we would replace all the x's in this equation with a 10. So I would say f of 10 equals 10 plus 1 equals 11. So that's the basis of a mathematical function. It's quite simple. I want to expand that notion a little bit more. This may be accurate in mathematics or not, I'm not sure, but this is pretty accurate in programming. What if we wanted a function that had two different things that it was operating on, f of x and y? And I said f of xy equals x plus y. Well, then you would assume that if I said what's f of 1, 2, we would place all the first one, all of those, with whatever's in this first parameter. So we would put a 1 in place of all the x's, and then we would place a 2 in the place of all the y's. So then we would get 1 plus 2, which equals 3. So what if you had f of x y equals x times 2x plus y times 2y? Well, let's just go through. So what if we had f of 1, 2 once again? Let's just go through, replace all of the x's with this 1. So we would say 1 times 2 times 1 plus, and then we replace all the y's with this 2. 2 times y. And then that would yield the result 1 times 2 is 2 plus 2 times 2 is 4. Oh, and then this y should be a 2 because we were replacing all the y's with 2's. So we'd end up getting 2 times 2 times 2. And then that would yield 8, which means we have a result of 10. Okay, so basically you just replace all of the appropriate parameters, what's inside this thing, with all of their parameters over here. And we could refine this even more. We could say when we have some replacements in those parameters, like over here, these are arguments to this function f. So let's get all of our terminology straight, okay? So this function takes two parameters, x and y. When we supply those parameters, when we're calling this function with two numbers, we say these are the arguments to the function f. And then what we do with these arguments is we simply replace the parameters in the equation with these numbers. Okay? This is the whole basic premise of programming. And so then we're going to expand this just a little bit more. So in programming, you can actually name a function anything. You can name it something like print. And then your parameters can be any sort of type in a programming language. And if you recall, we have our floating types, our integer types, our string types. So we have string, we have floating point numbers, we have integers, which are just numbers. And then we also have true values. We have false values, so truth values. These are the different types of things we can pass to a function. And we've actually been using these all along. If you remember, we've been using this thing called print, and then we just give it a string. So like, we just give it this. What's actually happening is we're calling this function print with the argument of this string, and then it's doing something with that argument, which is printing the result to the screen. Okay, so if we wanted to create a new function like maybe square root, which is the equation we just did, and this is actually what we'll be doing in just a second. Say you wanted to define a function in Python, it would be literally just like this. You would say define def square root, the name of your function. I'm just going to do sqrt parenthesis, and then you would give your parameter name. You're taking a number. You can give it any sort of variable name you want. And then you would give a colon, and then everything would be indented one space, and whatever is indented one space is all part of this function. Then how do you tell what to do? What if somebody calls square root? How do we know what the heck that does? Well, you could have square root return a value. So when we said f of 1 equals, and then we plug everything in everything, we get an equal sign. So like if f of x equals x squared, and we say f of 1 would equal 1. Well, how do we know that? Well, we're returning the value. We plug in 1, and then we get 1 out. How do we get the 1 out of this function? We would say return, and then we return some variable that we declared up inside of this function. And this will all make a little bit more sense too once we actually start coding. But the basic premise is we define some function name. We can give it whatever name we want. We define a parameter. We can have however many parameters we want, separated by a comma. And then we can have a return value, which means we are returning something from this function so that if someone wants to know what the value of it is, then they will know it is whatever is being returned outside of that function. Okay? So with this little bit of a basis, let's actually try and code this square root function real quick and see how it works out. So now that we are armed with our knowledge of what functions are, let's try and code this in this temporary.py file. I'm going to replace it with this code that I had just a second ago. And then we're just going to put this down here a little bit. And then I'm going to type in define, def, square root, sqrt, and then it's going to take in a number. All right, we'll actually just type out number completely, colon, and then notice how it automatically indents the next bit. That's because everything after this is going to have to be indented. So then we can just say something, whatever we want to do with this function and return a value. Well, what do we want to do? We want to do this, right? We want to have a whole number thing. So let's copy all of that part. And then let's actually indent it so that they're all indented on the same place. And then we know we're going to want to return a value. We're going to want to return x, which is the value we were printing down here, because that's the value that holds what the actual square root is. It's being modified in here. And we know that that's going to have the square root of whatever the number is. Okay, well, how do we know what number they're passing in? Well, that's inside of this variable called number. So instead of saying s equals x up here, like we were doing x equals enter a number right here, instead of doing that, we would say s equals this number. Now what we can do is we can say x equals the square root of whatever the user enters into here. Or actually, we'll initialize x to be the input once again right here, and then we'll say x equals the square root of x, which means x is going to be assigned the square root, which is whatever this is doing it, of whatever they enter. And then just to make sure it worked, we'll say print estimate, and then we'll pass in the x value, of course, with a string little wrapper around it to make sure that we can pass this all in together. So if we do Python and run this one more time, and we say 4, it gives us 2. We say 25, gives us 5. So it's all working just as we would expect. And to dive a little bit deeper, let's just see what it looks like with a number. So if we plugged in 5 here, then what would happen is 5 would go into here where this number variable is. Then we would say s equals that number, which is now 5. So s is 5. And then we would say xn equals 1, and then we would continue with the loop and just perform the algorithm. Let's do one more function just to try and really hammer down what the heck is happening. So we'll make this one a little bit simpler. We'll just say print message. So we'll say define print message, and then we'll take in a message, and then we will say print message. So this is literally just going to print whatever they pass in. So we'll say print message, and then we'll just pass in this is a message, and that should be all we have to do. So then if we run this, we'll run it one more time, it just prints out this is a message. So what's happening is it's just taking this, putting it in here, and then executing whatever this is. The reason this is so useful is because if we have a group of statements like this, then we can call it again right here. And then if we run this one more time, you'll notice it does it twice. And so this is very useful because we can actually call several different things. So we can group together, like say you're doing something several times like a square root, you wouldn't want to type out all the code for that to do it each individually once. Instead, you'd want to put it into this function, and you would want to call something called square root that does all that for you just automatically. And so this is really where functions are very useful. It's still a little bit hard to wrap your mind around. I would definitely encourage you to play with it, try a few different things, and then see if you can get it working. I would suggest trying to do some of the other problems we've done and implement them as functions instead, and then just see how it goes. One more note about functions is that you can define them with no parameters. So you could say define print hello, and I give it no parameters, and then if I just say print hello, you can still call that down here. If I say print hello, then it will still call this function, and it still works just fine. Just make sure you don't supply any arguments inside of these parentheses. And if you do end up doing that, Python will give you an error, and it says it takes 0 arguments, but 1 was given. So that's just saying you put something in here, but you shouldn't have done that. Okay, so use this knowledge, try and come up with a few different functions. I'm going to look at a problem real quick that I'm going to encourage you to try and solve yourself with a function. Okay, so what I'm going to encourage you guys to try is to implement the sine function, except as an actual function in a programming language. So you can actually estimate sine. I had an equation just a second ago, right down here, that shows how you can estimate what the value of the sine of a number is. So this function right here is actually going to give you an estimate of what sine at that value is. So I encourage you to implement this as a function, define sine of x, and then input all of this algorithm. And I would say go up to 11. So like go up to x to the 11th just to make sure that you get some good accuracy, and then try it out. Type in sine of a few different numbers and it should work as expected. Or if you do sine of pi, then it gives you 0. Yeah, sine of pi is 0. And then sine of pi over 2 should be 1, and so on and so forth. So give that a try and implement it. We'll go over how to do that in the next video. Okay, thanks for watching. If you guys enjoyed this, please hit like and subscribe, and I will see you in the next tutorial.